Greetings, everybody. This is the first set of notes in the Freshwater Resources Unit, which is ES8. These notes are called ES 8.1, the water cycle and water availability. And that's the title of these notes. You can write them down or type them out at the top of your page in a slightly larger and bolder font than what you might use ordinarily. For the rest of this set of notes, you'll be writing down everything that you see in orange text. If you feel like it's going too fast, feel free to pause the video. And at the end, there is a catch-all slide that has everything that you need to write down. The water cycle. Water is everywhere, from the heights of the atmosphere to deep within the planet. Water moves around the world through the hydrologic cycle, which is powered by the sun. The water cycle, geologic forces, and human usage all impact how much fresh water is available. So the hydrologic cycle, that's just a fancy word for the water cycle. Here's a picture of a Antarctic scene. The water cycle includes many processes, and some of these you've learned already, such as evaporation, condensation, and precipitation. Evaporation, of course, is liquid to gas. Transformation, phase change. Condensation is gas to liquid, and precipitation is rain or snow. As water molecules move through the water cycle, they can also freeze and melt, as we saw in the picture on the previous slide. But there's more than just these processes. This water cycle from the U.S. Geological Survey is perhaps slightly more detailed than what I would want you to remember. But there are some new words that I want you to know, and I want you to include in your water cycle when we draw it. One of those terms is transpiration. Transpiration is the process by which plants return water to the atmosphere during photosynthesis. So photosynthesis is how all plants get their energy from the sun, and during that process they also use water, usually taken up through the roots. During the chemical reaction that photosynthesis is, water is returned to the atmosphere. That's called a transpiration. Infiltration. Infiltration is when rainwater seeps into the ground. So it has to be a permeable surface, someplace where water can seep into the ground. So not like a blacktop, but a field of grass and soil, for example. Sometimes infiltration is called percolation. In order for this to happen, like I said, the ground has to be permeable, which means water can pass through. So permeability is important here as well. Runoff. Runoff is the draining of water from the surface of the land. Usually when we think of runoff, we think of impermeable surfaces, a lateral motion of water along the surface that can happen on pavement, on streets, but it also happens when the ground is saturated. This here is an example of storage. This is a big swamp. And another part of the water cycle is storage. It's when a large amount of water is stored for a long period of time, relatively speaking. This could be the ocean, a lake, or a glacier. Storage also occurs in aquifers. Aquifers are large pockets of groundwater that are in contact with impermeable rock. So impermeable rock means water cannot pass through. So if water is stuck underground, surrounded by impermeable rock, that can be storage as well. So that water is not exactly in motion. But the water cycle is all about the motion of water around the planet, and it's powered by the sun. And here is a incomplete water cycle. You see it's got the word percolation there. That's another fancy word for infiltration, or water seeping into the ground. But if I were to complete this water cycle, I would definitely add storage somewhere. I would have like a lake or something, and that would add runoff. I think that's it. Another thing we're going to talk about in this set of notes is freshwater versus saltwater. In different stages of the water cycle, water can either be fresh or salt water. Fresh water is the type of water we drink to survive. You can't drink salt water. Freshwater has lower concentrations of dissolved salts than seawater. So what makes a saltwater salty is dissolved solids, dissolved ions. Freshwater can be found in lakes, ponds, icebergs, springs, rivers, aquifers, and streams. Here's a picture of somebody kayaking on the James River. This is near, not that far from Binford, actually. This is on the Bell Island Rapids. Salt water is, of course, found in the ocean, but it's also in some inland salt lakes, such as the Caspian Sea and Utah's Great Salt Lake. So there are some salty lakes, but for the most part, salt water is found in the ocean. This, I believe, might be the Dead Sea, which is an inland salt lake in Asia. Brackish water is a mix of fresh and salt water, and you find that in estuaries. Estuaries are where the river meets the ocean. This picture is of a bull shark, and they're known to enjoy brackish water. So we all need fresh water to survive. We drink it. Without fresh water, most plant and animal life on the planet would perish, including us. Just a side note here, if you're ever shipwrecked or lost at sea for an extended period of time, do not drink salt water. It will dehydrate you and make you go insane. The salty water causes your cells to lose the water they need through osmosis. So that's taking it back to physical science there. Here's just a quick vocabulary word to know, desalination. Desalination is the process of taking salt water and turning it into fresh water. It's very expensive, and the only countries that generally do it are very wealthy and arid regions. It's important to know that Earth's freshwater supply is finite, and that means there's a limited amount. So it's like the opposite of infinite. It's finite. There's a limited amount. And some parts of the water have a very limited freshwater drinking resource. And here's a couple of pie charts, each pie chart subsequently showing a smaller amount of water. So all the water on Earth, 97% is salt water, and then that 3% sliver can be divided into surface water, ice caps, groundwater, and then the surface water, that 0.3%, is divided into lakes, rivers, and swamps. So Earth's surface is about 71% covered in water. So the rest is land, but 71% of Earth's surface is water. Most of that water is salt water. 97% of the water on Earth is salt water, either in the ocean or other saline waters, like the first pie chart shows. That leaves about 2.5% as fresh water. Unfortunately for us, 2/3 of that 2.5% of fresh water is trapped inside the polar ice caps, and thus it's not available for drinking. So only about 1% of Earth's total water is available for, 1% of Earth's total water is available for human use. And that water is found as groundwater, lakes and rivers or swamps. A small portion is found inside of all living things, and there's some water in the atmosphere at all times. Here's an interesting satellite image of an important freshwater resource in the United States and Canada. The United States is fortunate because we have abundant freshwater resources here compared to a lot of other countries. And the main reason for that is the Great Lakes. There are 5 Great Lakes: Huron, Superior, Erie, Ontario, and Michigan. And these lakes are remnants of glaciers that melted at the end of the last ice age. So during the last ice age, the whole northern part of North America was just covered in ice. And that ice melted, and the Great Lakes are what's left behind. We also have a big aquifer. So remember, that is a pocket of groundwater. It's called the Ogallala Aquifer. And it's in the United States, and it's huge, but it's also being used up faster than it can regenerate because of agriculture. So people are pumping the water out of the ground to water the crops, and because they're using it so quickly, rainwater would ordinarily replenish it, but it's not happening fast enough. Even though fresh water is plentiful in the U.S. on the whole, certain areas like Southern California are prone to drought and face water shortages. California has a huge population and relies mostly on irrigation water pumped in from other states. The Colorado River, for example, is where Los Angeles gets most of its water. Another side note, what's the deal with water towers? You've probably seen these sitting around. This is what creates water pressure that you enjoy in your home. If you've ever taken a shower in a house that has poor water pressure, it just kind of trickles out. But water towers are elevated water tanks that maintain that water pressure. So here is the catch-all slide where you have everything that you were supposed to write down throughout this set of notes and a couple of images that I chose. The images aren't necessary for you, but you can put a couple images if you have room. You can also, if you need more than one slide, you can use more than one slide. And that's it for the first set of notes for freshwater resources.